Today we are discussing about length of smooth curves represented by parametric equations. Let phi be a smooth curve represented by the parametric equations x is equal to f of t, y is equal to g of t with parameter interval closed interval AB. So phi is a curve defined on a closed interval and it is represented by x is equal to f of t and y is equal to g of t. If v does not intersect itself except possibly for t is equal to a and t is equal to b, then the length of v is given by L is equal to integral a to b root of f dash of t the whole square plus g dash of t the whole square dt is equal to integral a to b root of dx by dt the whole square plus dy by dt the whole square dt. So, this can be used for finding the lengths of smooth curves which are represented by parametric equations. Now we can have two examples. Example 1. Find the length of one arch of the cycloid x is equal to a theta minus sin theta, y is equal to a 1 minus cos theta. Our cycloid is like this. Here, one arch of the cycloid is traced out by letting theta runs from 0 to 2 pi. So, the length can be calculated by L is equal to integral 0 to 2 pi root of dx by d theta the whole square plus dy by d theta the whole square d theta. Now we can find dx by d theta and dy by d theta. Dx by d theta is equal to a into, we have x is equal to theta minus sin theta, therefore 1 minus cos theta, and dy by d theta is equal to a sin theta. So L is equal to integral 0 to 2 pi square root of a square 1 minus cos theta the whole square plus a square sin square theta d theta. Expanding the square, we have integral 0 to 2 pi square root of a square 1 minus 2 cos theta plus cos square theta plus a square sin square theta d theta. And this is equal to integral 0 to 2 pi. Taking a square inside, we have a square minus 2a square cos theta plus a square cos square theta plus a square sin square theta, and that is equal to a square. So, the length is integral 0 to 2 pi a square minus 2a square cos theta plus a square, and that is equal to integral 0 to 2 pi square root of 2a square minus 2a square cos theta, or this can be written as a times integral 0 to 2 pi root of 2 1 minus cos theta d theta, and we have sin square x is equal to 1 minus cos 2x by 2. If we are substituting 2x is equal to theta, we have sin square theta by 2 is equal to 1 minus cos theta by 2. Now we are replacing 1 minus cos theta by 2 sin square theta by 2. That is, this becomes integral 0 to 2 pi square root of 4 sin square theta by 2 d theta. That is equal to 2a integral 0 to 2 pi sin theta by 2 d theta. Since sin theta by 2 greater than or equal to 0 on closed interval 0 to pi, so we can consider the positive value. We have the integral of sin theta by 2 is minus 2 cos theta by 2. Therefore, this becomes minus 4a cos theta by 2 0 to 2 pi, and that is equal to minus 4a cos 2 pi by 2, that is cos pi is equal to minus 1 and cos 0 is equal to 1. So this is equal to 8a. Now we have the second example, example 2. Find the length of the curve x is equal to 2t square, y is equal to 3t cube, where 0 less than or equal to t less than or equal to 1. So here we have to find the length of the curve parameterized by the equations x is equal to 2t square and y is equal to 3t cube, and the interval is given here. So L is equal to integral 0 to 1 root of dx by dt the whole square plus dy by dt the whole square dt. Now we can find dx by dt and dy by dt. Dx by dt is given by 4t and dy by dt is equal to 9t square. Therefore, L becomes integral 0 to 1 square root of 16t square plus 81 t raised to 4 dt. Now we can take t square outside of the square root, then that becomes t, and integral 0 to 1 t (16 plus 81 t square dt). Now we are integrating this by substitution, so we can substitute 16 plus 81 t square is equal to u. Differentiating on both sides, we have 162 t is equal to du by dt, or t dt is equal to du by 162. And here the limit changes from 0 to 16. and 1 to 97. So the integral becomes integral 16 to 97 root u du by 162. That is u raised to 3 by 2, 2 by 3 into 162. Varies from 16 to 97. That is equal to 1 by 81 times 3, 3 times 81, 97 raised to 3 by 2 minus 16 raised to 3 by 2. And that is equal to 1 by 243, 97 raised to 3 by 2 minus 64. Now we can have another example. Find the length of the asteroid x is equal to cos cube t, y is equal to sin cube t, where 0 less than or equal to t less than or equal to 2 pi. So we have to find the length of this. Here this curve is symmetric about both x and y axis. So to find the length of the whole curve, it is enough to find the length of the curve in the first quadrant, and we can multiply that length by 4 to obtain the length of the whole curve. So here we are going to find the length in the first quadrant, and to obtain the whole length we multiply this by 4. Now dx by dt is equal to x is equal to cos cube t, therefore dx by dt is equal to 3 cos square t minus sin t, and dy by dt is equal to 3 sin square t cos t. Therefore dx by dt the whole square plus dy by dt the whole square is equal to 9 cos raised to 4t sin square t plus 9 sin raised to 4t cos square t, and we have sin square t, cos square t and 9 are common to these both the terms. So we have 9 cos square t sin square t times cos square t plus sin square t, and this quantity is 1. Therefore this becomes 9 cos square t sin square t. Now we can consider the square root of this. Root of dx by dt the whole square plus dy by dt the whole square, that is equal to, we are taking this square root in the first quadrant only, so t varies from 0 to pi by 2, and in that case we know that cos t and sin t are positive, so by taking square roots we have 3 cos t sin t. Now L is equal to 4 times the length of the curve in the first quadrant, that is 0 to pi by 2, 3 cos t sin t dt, and therefore we can write it as integral 0 to pi by 2 2 cos t sin t 6 times dt. This is equal to 6 into 2 cos t sin t is sin 2t, therefore integral 0 to pi by 2 sin 2t dt, and the integral of sin 2t is minus cos 2t by 2, therefore minus 3 cos 2t 0 to pi by 2, and that is equal to minus 3 cos pi, that is minus 1, cos 0 minus 1 is equal to 6. So here the length of the asteroid is 6. Similarly, we can find the lengths of other parameterized smooth curves. Thank you.